Okay, this is AWS IOT Twinmaker launches enhancements for scaling digital twins and building data connectors. So digital twin, that's an interesting idea. So the idea
That's actually a fascinating idea. This is part of the Industrial 4.0 revolution. And just for the audience, the digital twin is nothing but a virtual representation of your physical infrastructure. So let's say you had a machine that is producing something, or you had an assembly line, or you had some kind of a workshop that's producing certain goods, or you have a supply chain, doesn't matter. Whatever your physical system is, you can actually start, you can use CAD modeling to create a virtual setup of that, and then start streaming all of the sensor data that you are collecting across all the sensors across the factory or the workshop or whatever you've got. Take all of that data and that material and pass it on to your virtual device. You can then train that virtual version of that device to mimic the behavior of your real physical system. Now imagine what that means for factories, or imagine what that means for plants and machineries. You can use that mechanism to predict failure of the plant or device or specific parts. You can use it as a mechanism to figure out, how key metrics would operate. You could run a bunch of different simulations. There are numerous use cases that come out of the IoT Twinmaker service. So yeah, I'm actually pretty kicked about it. To be honest, we haven't built anything with it yet, but we are just about to kickstart a project where we're going to be leveraging the IoT Twinmaker to really understand what's happening with a lot of our own internal processes.
Well, that's exciting. It'll be fun. I think we should do a special episode dedicated to that when it's all up and running. So I'll mark that down for a future one.
Correct.
It's interesting. I think about a long time ago in grad school, I had a roommate, and he was in operations management, and he was looking at, he was a classmate of mine, and he was looking at a hospital, and he was designing a new process for the elevator management of this hospital. And I can see, he had to do all these calculus-based queuing theory stuff on service time and inter-arrival processes, and being able to validate that or pair that with a simulation based on, well, at first you would do a digital twin, and then you could also do real data based on, say, the sensors at the elevator. That would be a really neat way to kind of make an empirical addition to that research.
Yeah, completely agree. And by the way, since you brought up elevators, I've been fascinated by some of these elevators that are now available, where the button you press to get to whichever floor is outside the elevator and outside of the, like, you don't make the choice of the floor you want to go to inside the elevator, you make it outside. And it tells you which one of the elevators to go to based on whatever optimization it runs. And when you really think about it, that is so simple to implement, and it is so much more effective in reducing congestion. I wonder why no one thought about it earlier.
I used to work in a building a long time ago in Brisbane, Australia, that had one of those. And it was neat because there's peak periods, right? When everyone's getting back from lunch or everything, where they can do preemptive things. Like they can have a policy of, if the elevator takes someone up to the 10th floor, just return it right back to the lobby.
Correct.
And it makes so much room for that. It's actually interesting. I remember I looked at this a long time ago. The elevators are a huge portion of a building's footprint. Especially for skyscrapers. And if you can reduce the need for it while maintaining a quality of service, you get a huge amount of savings, especially over the lifetime of the building, right? How much is 100 floors of, 50 square feet over 50 years worth? It's a lot. So being able to save them. Although I think the way they used to do it, when they first came out, where the elevators were like ski lift and you just had to jump in. It was going on the way up. Oh, that would be terrifying.
Yeah, agreed. So yeah, so Twinmaker is actually really neat. Um, you guys should all try it out. We are going to do the same at our end with this new project that we're just kicking off. But yeah, I think the Twinmaker setup with I think there's a service called SiteView as well, which manages temporal data. So yeah, this is a amazing tool for a lot of understanding what's going on at the process level. So yeah, folks should use it. You can figure out whether your parts are about to die or get ruined, whether you need replacement parts, whether you're operating them at peak efficiency or not. You can gather all of that data in one place.
I'm curious to see how much work it is to get your twin to truly mimic the more complex behaviors of the actual system that you're trying to model.
Yeah, I think the amount of data that you collect becomes a big driving factor for that. The more data you have, the twin is actually able to learn from that data and create all these interesting scenarios that can then, yeah, it's fascinating.
Yeah, and it represents a bit of a shift in thinking about models, right? Because from
Yeah,
a academic perspective, a model meant equations that govern the fundamental physics or fundamental properties of the system. But if this is based on actual data and it's saying, well, I know that for any scenario, if this goes in, this goes out, it's more like an empirical model, but it's equally useful, if not more so. All right. Well, anything else
agreed.
you can say about twins before we move on?
No, I think that's it on the digital twins.
Got it. All right. Well, let's do a transition. Let's take a quick break, and then when we shift back, we will